I'm Alex Chiquito. I'm from Mexico, but been living in Sweden for 6 years now in Luleå. I'm actually a system architect in Sinetiq. We are a group of very experienced people in component-based architectures and API-first ideas. And I also have a PhD in cyber-physical systems. I focused my research on authorization mechanisms for component-based architectures. So a lot access control. And deep inside me, I'm a metalhead gamer and overall music lover. Yesterday, we had some talks about monoliths and microservices. In conclusion, we can say the trends are moving away from a monolith into more component-based architectures. And even if your monolith is, well, a monolith, you still need to communicate with some other components to perform a task. It's not news, but this is through APIs, as you all may know. And I think I don't need to actually defend this slide because, well, we know that these bridges that connect and communicate data, we need to safeguard it in some way. So because every API, it's more surface for attacks. And this is in some way put into the OWASP top 10. You probably know the OWASP. Is the go-to guide for security related topics. This is a subset of the top 10, but I really like specifically the first one. Not biased because of my research topic, but broken access control. And I actually lied a bit in the beginning. This is actually a talk about access control. And it is a problem that even the most secure locking organizations may not think or may not realize they have it. It can be pretty much summarized as someone getting unauthorized access to sensitive data. And the OWASP have a lot of weaknesses and common attack points, but I want to take several of them that are especially critical for APIs. And I'll give you a bit of an example. Before coming to Sweden, I was a data analyst. So there were a couple of times that the business comes to me and asks for a dashboard, a really nice dashboard with data to show to, I don't know, their manager or in some presentation. And they give me a report and they tell me, okay, this report has some sensitive data, cover your eyes, delete the columns that you shouldn't see, and well, give me the dashboard at the end. I am a pretty good person. A bit curious, but good person. But imagine if a curious but a bit malevolent person gets access to this and can actually see the Power BI and the columns that I deleted. It's a bit spooky. And there's another example, a bit more of a real life. American Express had a security breach last year. The interesting thing about this is that American Express systems themselves were never compromised. It is a very secured environment, but it was a third-party system which they use for traveling that was compromised. This is spooky because as secure as your environment seems to be, it's as weak as the weakest link on the chain. And there's some tools that you can use to make these chain links stronger. And one of them is taking care of excessive data exposure. We as developers, we like our APIs to have many different use cases. I think they mentioned it in the panel in the morning. These monolithic APIs that we think, okay, this will work for several use cases, they can leak sensitive information such as the account of a person that probably they don't need to see it, or go against the GDPR, getting the address of a person, or even, it's business logic that you are leaking in your API. Now someone that sees this can know that in order to be a VIP customer, they just need to put that field in an API call. And well, you've heard this a lot today or yesterday. The principle of the least privilege, basically, you want to give as least information possible for anyone to perform a task. And this can be aided by API segmentation. We also talked about that in the morning. If you take your monolithic APIs and try to make them into smaller endpoints, then you can actually control who can access to the public profile or the loyalty program API. But then we have this scenario where you have thousands of very fine granular APIs after your segmentation project. And now we need to ask the question, who can access what and when or under which circumstances? And I like to give an example of my office. I have a badge that I can put on the door. But once I'm inside, I can go to the copy machine, see what papers are there. I can go, I don't know, to the bathroom. I can take a banana from the fruit stand. But the idea is, once I'm inside, I'm trusted. But what would happen if someone takes my badge or just tailgates behind me? It's a bit spooky. And this is actually a model that, it has a name. It's the moat and castle security model, where you have a very secure moat and walls in your perimeter. You have a firewall, VPNs and such. And once someone is inside that moat or that secure perimeter, they have access to basically everything, which is spooky. Someone came up and said, okay, now we shouldn't trust anyone, and zero trust security came up. And the words never trust, always verify. They basically gave you a guard behind you that is asking, are you allowed to take this banana? Are you allowed to go to the bathroom? Ensuring that you have the least amount of privileges to make your work, no more, no less. This is actually, I like to put a big asterisk on the zero, because making that in reality is a bit hard. You cannot have the guard behind you every time. And one example that I like to give is here in Sweden, every time you go to your banking app, you need to bank ID and authorize every single transaction, which makes sense. You are talking about money. But if you go to Netflix and want to see, I don't know, the Fallout series, you don't need to bank ID into, yes, that's me, I want to see the series. So there's some level of zero trust that you need to put depending on the sensitivity of your data. So who can access what and when? This is solved by my beloved access control. And the idea is simple. You want to relate subjects to resources in some way. And the easiest way, the way that it's been done since the beginning of computers, it's an access control list. You have a matrix basically with subjects and resources, and you list every single one. But imagine how hard is doing that in today's environment. We have, however, some evolutions as role-based access control, but it is still not coping with how hard and complex things are nowadays. Now, if you have a system that does a lot of things, you can take some shortcuts and say, okay, give the role of an admin, and it will work. So you are breaking this least privilege principle by making things harder for yourself. And that's where attribute-based access control enters. Specifically, the next generation access control, which I'm a fan of. Not because I made my PhD about it, but because I actually think that it is useful and a good alternative for attribute-based access control. It's basically a policy language, as there are many of, but it's a graph-based policy language that is characterized by being flexible. And, well, the idea is basically you have users on one side, user attributes, and you have objects and object attributes, and you want to connect them with associations between them. And at the end, you create a directed acyclic graph, just a fancy word for a graph, which has some algorithms to go through it in a efficient way. So if you want to see that if a user have access to some resource, You just need to go to the graph and see if there's an association containing the access right. In this example, it's a very simple example, but it's just read and write, or you can be fancy and put some constraints or context-dependent policies in those associations. But the idea is simple. You create the graph and transverse it to see if certain user has the power over certain resource. And this is applied in the same way as I think we had a presentation yesterday with David where he posted this same picture. The NIST attribute-based access control architecture. The idea is we have an enforcement point intercepting the calls, every single call from a user. I'm calling them users, but take a note on that, into any resource. And this enforcement point takes the request, deconstructed, and asks a decision point if it is authorized, basically, with some information point on one side asking for attributes and a PRP, a resource point on the other side asking for the policies. And hopefully some of you can see this architecture and try to see it in the context of APIs because, well, this talk was about API security. And we have an API secure gateway, which an API gateway is something that intercepts the data. We all know the calls. We all know that. So an API security gateway can take the role of an enforcement point and validate each and every request with against the policies and basically help us to enable some sort of zero trust and least privilege principle, of course, depending on your policies. And the idea is we should have an API gateway, and we basically just reconnected. And this API security gateway does the same task as the API gateway does with login, monitoring, and so on. On top of that, we also have the enforcement of policies, validation, schema validation, and some data cleaning to make sure that everyone only see what they need to see. But this talk is actually about trade-offs. Because there's no free lunch. We actually paid for the lunch before. And I was expecting actually for the audience to be fully Swedish, my bad. But I'm learning Swedish and there's a real nice word that is lagom. I learned it some weeks ago. It's the magic in between. It's not too much, not too little. So on one side, we have low management overhead. It's very easy to implement coarse-grained access control that probably the project managers are very happy about it because it's easy to maintain, but it's pretty weakly secure. While on the other hand, we have this spooky, hard to maintain, complex to implement, fine-grained access control. But at least me, my homer would be looking at the other side and, yeah, this is perfect, but maybe it's pretty hard to sell this into actual projects and real-life applications. But cybersecurity and API security in itself is not that simple. There's a lot of different sectors or things involved in API security. And this talk was mainly about authorization and authentication. Actually, just authorization. But you still need to have some usage control so that if you get access to some data, what can you do with it? Can you take your phone and take a photograph and just send it to somewhere else? So you need some legal agreements because, well, that is pretty hard to actually implement in real life. And, well, the good old stuff, you need to make sure that the channel you are communicating through is secure and that the machines that are interacting in this exchange of information are technically certified. So I have a couple of conclusions. First, security APIs is not just having the most fancy encryption mechanism. A lot of it comes into the design table. if we think of our APIs in the sense of having the least privilege principle in some way, segmented APIs, and applying things like zero trust in API security gateways, we can make our systems resilient by design. And overall, perfect security doesn't exist, or at least not yet. Some of the most perfect systems can be just sent to the trash by someone having deposited in the password in deposited in a monitor. So, but fixing broken access control is definitely a step in the right direction. The discussions would be later, but the thanks still apply. Thank you. Awesome.